All right, welcome everybody. Hope you're having a great evening. My name again is Brian McLogan, and what I want to do in this live stream is work on a homework assignment for the law of sines. Now, I did make a mistake as I left my classroom today, and I forgot my calculator, at least my TI calculator, which I used in the classroom. So therefore, fortunately though, we have this TI 30X at home. So I'm going to go ahead and work on this just to kind of get used to it. I'm not as used to it, though, as using a TI, as that's what I used for many, many years. So I think we'll be okay. And then also, unfortunately, I forgot I didn't bring my software, so I'm not able to like display the calculator on the screen, which would have been awesome. So I do apologize for that. But regardless, we'll be able to get through the stream. You guys can see here what we're going to work on is, finding all the missing sides of a triangle using the law of sines. We'll work on how to determine if it's 1, 2, or no triangles. We'll work on a word problem, and then we'll also work on some multiple choice. Now, I wrote down those multiple choice. Yeah, so this one, that's a mess up. So we'll come to that. Either way, guys, glad for you guys to go ahead and join on the stream. So here's some people, Tommy, Avery, Xsteel, Abel's being very nice, Christine, the Kitty Gamer, good to see you, Kobe, Carlos, glad you guys could make it for the stream. Hopefully I'm covering something that you guys will be able to help you out. And obviously, if you guys have some questions on anything that I'm covering, anything I say or anything I do, please feel free to let me know in the chat. And what I'll do is I'll try to take a quick little break. I'm not going to take as long as break I've done in the past, but I will take a quick little break here, just kind of see if there's any points that anybody makes regarding the first 3 questions. If not, then what I'll do is I'll just kind of wrap up the multiple choice as quickly as I can. I'd like to kind of get this stream over with here in roughly around like 40 minutes, and then if I have around 30. Yeah, around like 30 to 40 minutes. And then whatever time, if you guys have some homework questions, then I'll kind of go from there as well. So I see Carlos kind of adding the chat, having some homework questions. Again, guys, I did it. I didn't really get some feedback. So we'll just keep on playing with it, and maybe this will start to be a trend eventually. But obviously, if you have some questions, I'm trying to post advanced on my live streams. I'm planning on going Tuesday and Thursdays. So if you do have some questions, or if you want to send some pictures on my Facebook website, which I believe I have in the description. Maybe not. No, I don't have it in the description. So I'll add it to my descriptions as far as my Facebook profile or my Facebook page, where therefore you can kind of see those posts. And if you have some questions you want to pre-submit that you'd like me to explain or talk about, then I'll be more than happy to do it as long as I have some time. Otherwise, I have to try to somehow scroll through the feed and figure out if I can understand your understand your question in that time, and I know in the chat it's not always the best. So, all right, let's go ahead and get started on the law of sines. All right, so we went over this. So hopefully, obviously, guys, the law of sines. I mean, you guys can quickly go ahead and search it, whatever you need. I'll kind of talk my way through it. I'm not going to write it down because obviously that hopefully is something already for in your notes. So in the first one, though, I'll at least kind of go through the setup that I want for my students to be able to have when I'm grading this on a quiz. So it says find all the missing measures of each triangle. All right, so the first thing we want to do is just kind of sketch a general oblique triangle. Doesn't need to be perfect, but we just want to kind of get a general idea, and I didn't really think about trying to draw this with this tablet. All right, so we have A. Let's call this B, and let's call this C. So therefore, this is 46.5. C is 64. And then the nice thing we can figure out about B is that by the triangle angle sum theorem. So just to make sure that I'm not doing anything correct, we know that B is going to be 180. So all the angles of a triangle, right, add up to 180. So 64 minus 46.5. And that equals, so I'm just going to do it rather than trying to test my mental math in front of everybody online and then making some careless mistake, is 69.5, which I definitely could have done whatever else. But there you go. So that's 69.5 degrees. Awesome. And then we do have one side length, which is C is 14, lowercase c. Okay, so basically just with, all I did was figure out the third side of the triangle, and then R was given one ratio. So this is an angle side problem, and when we're doing law signs with angle side problem, we should be pretty happy. We should like these. Basically, all we need to do in this case is we already have a ratio, so now I just basically need to create a ratio here to solve for my missing lowercase a and lowercase b. So what I'm going to do is I'm going to set up the law of sines with my current ratio of 14 over the sine of 14. And again, I'm going to put the side length in the numerator because that's what I'm going to be solving for. So I'll say a over, the sine of 46.5 is equal to 14 over the sine of 64 degrees. Okay, now if I'm going to solve for a, I'm going to tell you what I'm going to type in my calculator, so at least I'll show it this time. So I'm going to solve for a, you'd multiply by sine of 46.5 on both sides. So it'd be 14 times the sine of 46.5 divided by the sine of 64. And again, these are degrees. I should probably clarify that, right? Make sure a little degrees. Okay, so that's what I'm going to type into my lovely calculator. Again, guys, when you're using a calculator that you're maybe not used to using, or you're just grabbing one from your friend, make sure it's in degree mode for this chapter, or when you're dealing with angles that are in degrees. Up to this point, we've been mostly dealing with radians, so that's why it's important to make that change. So I'll do 14 times the sine of 46.5, and then divide that by the sine of 64. Okay, and now I am going to round to the nearest thousandth. I'll just have that equal to 11.299. Okay, now if I want to figure out what b is, I'm going to do the same thing. Now, even though I do have a ratio now for a, like I do have the side length and the angle, since I rounded this answer, and I can store it in this calculator, but I don't really want to use this as a calculated answer. So I'm just going to go back to my original information that I was given, and now I'm going to create a ratio with b. So I'm going to say b over the sine of 69.5 degrees is equal to the same ratio of 14 over the sine of 64 degrees. And I guess, you know what? I guess I might as well just write, why am I getting these ratios? Again, guys, the law of sines is the ratio of the side over its angle is equal to the side over its angle for all of the angles of an oblique triangle. And again, you can rewrite these anyway. So you could flip the numerator and denominators, and the proportionality would still be fine. So therefore, let's just go and write b here, just because I don't have a TI calculator, so I might as well just write out what I'm going to be typing into my calculator. And then that will be the sine of 64. So I do move a little bit faster here when I'm solving things, and I do kind of apologize. If you guys need some further explanation, let me know. But one of the things that, is obviously we do a lot of the same stuff over and over again. And a lot of it is just typing into your calculator, for instance, 14 times sine of 69.5 divided by the sine of 64. Oh, I typed in that wrong. So 14 times the sine of 69.5 divided by the sine of 64. Okay, and therefore for b, I'm getting 14.59, and 0 would be the next, so I just round it to the nearest tenth in this case, or hundredth. Now the important thing is, so I'm using a calculator I'm not used to, right? And now when I was playing around with this, working on some of the other problems, I found that one of the buttons kind of stuck. So I would hit 44 and only 1 4 would show up, and I caught the mistake because one of the main things on this chapter is, whenever you're solving a problem, or especially a word problem or a problem like this, make sure, go back to the problem, make sure the side lengths make sense, right? So we have one side length of C. You see these are all kind of acute angles. The angles are roughly going to be around 14. Well, I have 11 and 14. I'm looking good. So obviously if I would have got I think when I first typed it in, I got a side length of 0.9 or something. obviously I knew I typed in something wrong, so that's why I went back and retyped in the problem, right? Or if you would have got a side length of like 470, then obviously you typed in something wrong, or there's an answer somewhere that happened. Go back and check your work. So it's really important because, a little mistake can happen here or there. So it's really important to go back and make sure your answers make sense. Okay, but as far as my students go, I'm looking for a triangle, I'm looking for an equation, and then obviously looking for the answers. All right, so for the next one, let's go ahead and draw a triangle. Let's do a lighter purple on this one. So I'm going to draw the same kind of triangle because I like this triangle, AB, but you don't need to stick with this. You can draw the triangle really any way you want to. So this would be 50 degrees. C is 33 degrees. And then here we have 9 feet. I probably should have just left this off this one answer, but either way. All right, so in this case, again, we're up to our case where we don't have a ratio. Now, I wanted to provide this problem in here because a lot of students get stuck in this case because they'll look and they say, oh, we don't have a ratio. So once we teach law of cosines, they immediately try to do the law of cosines. And you got to be careful because this wouldn't work for the law of cosines as either. This is going to be a law of sines problem, and all we need to do is just figure out b, which again is the same thing of what we did in the last problem. Just take 180 degrees minus 50 and then minus 33. Now in this one I was typing in while I was talking, and therefore we get 97 degrees. Okay, so now that we have this as 97 degrees, I'll put this in there now. Again, we can do the same thing that we did before as far as identifying our ratios. We now have one ratio, right? And we're going to need to find our other two lengths, A and C. So I can write 9 feet over the sine of 97 degrees. That's my ratio. And this one, I'll just do it on the other side, is equal to A over the sine of 50 degrees. But again, it doesn't matter where you're solving for A, if it's on the left side or the right side. If I want A, that's just equal to 9 feet times the sine of 50, right? To get sine of 50 off the denominator, you have to multiply by sine of 50 on both sides, divided by the sine of 97 degrees. So let's go ahead and figure that out. So let's type in 9 times the sine of 50 divided by the sine of 97. And that gives me 6.946 as I round to the nearest thousandth. Okay? And then we can do the same thing with C. So I can do we have a quantity here. We have a dimension here, so this is in feet. So don't be careful. I put that in there for a reason, so people will make sure that they apply their units. All right, the next example is going to be C. So let's do the same setup again. So 9 feet is to the sine of 97 is equal to C over the sine of 33 degrees. And then again, I'll just write it out because I've already kind of started this, times the sine of 33 degrees all over the sine of 97 degrees. All right, so we have the sine of 33 times 9 divided by the sine of 97 and 4.9, which would make sense. So that's the smallest angle, so that's going to give you the small side. So that'd be 4.939 as I round it, and then again, just remember it's feet, right? As I get right off the edge of the paper. Okay, so that's the basic thing, 2 problems just to make sure you can practice, make sure you can get these side lengths correct. And here I just tell my students, if I don't tell you how to round, then round to the nearest thousandth. All right, so for the next one, we're giving this ambiguous case, side-side angle. And so this one's just asking you to determine 1, 2, or no triangles. Now, we talked about a couple different ways to do this, and so I'm going to kind of work on both ways for it to, kind of make sense as far as what we do. But basically, the main idea for this ambiguous case, which I know is very difficult to try to fully explain in, I don't know, a couple minutes. But basically, I just want to kind of get an understanding here, is if we have a triangle that's angle side-side. No, dang it. Okay, so we have a triangle. That's angle side, side. It looks something like this. Let's pretend we have our angle here, which is A. We'll have little a, and let's call this little b. Okay? Now, what's important about this is if here's our angle, right? So what we're going to be comparing here is our height, h. Okay? Now, there's our height. So what we're going to do is we're going to look into as identifying the height h. And what we're going to do is we're going to use the height h to kind of compare if there's one or two triangles. Now, the one thing I want you to understand, though, is here would be angle B, right? This is side length B, then this is going to be angle B, right? Well, if there is another triangle, or this, actually, you know what? Let's stop. Let's not over educate right now. Let's go ahead and do the problems with this, and then what I'll do is when I get to that problem, I will explain it a little bit further. All right. So I'm going to use this angle here for all of them. So I'm just going to draw a triangle. And I'm going to say, here's A, which is 43 degrees. I don't really care if it's A, B, or C. I just know I want my triangles, angle side, side, to look like this. Because, at least in my class, this is the diagrams that I use. So to figure out the height, okay, I'll do it once this time, and then hopefully I'll show you guys these patterns. To figure the height, you guys can see that the sine of 43 degrees equals opposite over hypotenuse. So therefore, the height is equal to this near side, right? The opposite side, little a, right, is across the triangle. So the near side times the sine of the one angle you're given. And this works every single time. So anyways, let's figure out what this is. So this is be 60 times the sine of 43. And that's going to equal 40.19. Okay, so the height is smaller than this side, or the height is smaller than both sides. So what that means is there's either going to be one triangle or two triangles. Now, obviously, this side length is going to be this side is larger than any other side. So the opposite side of your angle is larger than any other side. So the way that this works is A is fixed, right? We have A is fixed. This little side B is fixed. A is also fixed, but A is on this hinge. Now, again, let's just pretend A has to be bigger than B in this case, right? So let's draw this bigger. Now, again, this is on a hinge, and this side length B can be extended as far as we want. So what you can see is if we just rotate this side length to here, then you can create a triangle, and that's why the one triangle, this would be one triangle in this case. So I'm just going to write one triangle. Now the other point that I wanted to make with this is, actually, you know what? I think it's just too much for me to kind of cover in the live stream. But yeah, it's too much. I don't want to be here all night going through this. But I think that's the easiest thing, is understanding the h and the height. The other thing you could do is go ahead and just use the law of sines and figure out what your b would be. So if you just figured out what that angle b would be, and then what you'd have to do is see if there would be another case option for B2, another option, which I think it's a hard concept to kind of circle out. So I think the easy way to do it is maybe just drawing the triangle, identifying the height, and then trying to see which type of triangle would make sense. So let's look on the next one. Same kind of idea. Let's just draw another triangle and then go from there. So this one, we have A is 75 degrees. Here's 5, and let's just make this 7. Okay, so that's your angle, side, side, right? So again, if I'm going to do my height, I kind of know that this is going to be 7 times the sine of 75 degrees. So I just go ahead and take 7 times the sine of 75. And in this case, I get 6.76. Okay, so this is kind of weird. Like if you look at this triangle really looks like this. The height, right, is larger than the opposite side. So let's draw the triangle again. So here's 7, right? And let's just pretend this height is, I don't know, 6.7, right? Well, this side length is 5. So this side is not like, it doesn't matter how much you sway this, like in either direction, it's never going to create a closed triangle, right? So you have side length B, but it's not big enough to go from this point down. It needs to be at least a minimum of 6.7, right? Because that's the height of the triangle. So if you have your opposite side as 5, it doesn't matter how much you hinge the side, you're never going to create a closed triangle. So therefore, this is no triangle exists. And basically the way to remember this is when your height is going to be larger than your opposite side, then you're not going to have a triangle that's going to exist. So when this opposite side, then you can see that there's no triangle that would exist. So hopefully the next one is a two triangle case, I would assume. But let's go and check it out. Let's not assume anything. All right, so this would be A is 40 degrees. So this is 5.4. This is 6.2. So again, my height is going to be the near side times the angle. So that's going to be 6.2 times the sine of 40 degrees. So I'll type in 6.2 times the sine of 40. And in this case, I get 3.9. 985. I don't know where I rounded to the nearest 100 for the other two. I guess we'll just round to the nearest 100th, since that's what I did for the other two accidentally. So that'd be 3.99. All right, so what we notice here is the height is smaller than this side. Very good. But notice the difference here. Notice the difference between these two triangles, the first triangle and last triangle. This triangle, the opposite side is shorter than the other side, right? Than your near side. Whereas this one, the opposite side was longer than the near side. So again, like the difference in these two being, this one, I'll kind of draw it like in purple, so hopefully that makes sense. This one can kind of look like this, where you can rotate it outward to create a triangle. Whereas this one, since it's shorter than, you can rotate it inward, and that creates your two triangle system. So again, guys, like I don't want to get too much into this, but you guys can see that when the short side or the far side is shorter than this side, you can see how this creates this separate triangle that we can create. Okay, so that's where the two triangle case comes in. And again, the easy thing to remember is when you find the height, as long as your opposite side is larger than your height, right? So it can't be shorter. I'm sorry, it can't be bigger, right? So as long as your height is not bigger than your sides, then you have a triangle. So then all we got to do is compare these two sides. The far side, if it's larger, then it's one triangle. If the far side is shorter than the other side, then it's going to be a two triangle system. And we're going to spend more time in my class, developing these, and I have a lot more videos, explaining this concept, because it does take a while, and it takes, definitely some practice for people to really kind of get things to sink in. All right, so the last one here for the word problems is a surveyor is trying to determine the distance to 2 points that lie on opposite side of a river. So let's go ahead and draw a river. Okay, and let's go and draw a surveyor. We'll take the bird view from this, and the 2 points are 1,200 yards apart. So let's draw 2 points across the river, and let's say that distance is 1,200. So 1,200 yards apart from each other, and have angles from each other and then to the surveyor of 19 degrees and 21 degrees. So I am taking that as the angles between each other as well as to the surveyor are 19 degrees and 21 degrees. Okay. Then it's basically asking us to determine the distance from the surveyor to each point. So let's just call this distance 1, and let's call this distance 2. All right, so this would be, point 1, and this would be point number 2. All right, so again, to, kind of look at this, we need to create a ratio here. So basically, I need to figure out then what this angle is right here. So let's call this the C, I guess. So again, C equals 180 degrees minus 21 minus 19. So that would be 30, 40. So that would be 140, I believe. Just going to type it in just to make sure I'm not doing anything stupid tonight. And 120, jeez. See, like I can't even type in my calculator. This calculator is an issue. So I want to make sure. Yeah. So anyways, I have 140. So therefore I can create the law of sines, right? And again, we're going to try these two other side lengths. So therefore I'm just going to create a ratio with these side lengths compared to their opposite side. So therefore I can say 120 yards over the sine of 140 degrees is equal to, let's do D1. I don't know why I put a dot on there. D1 over the sine of 21 degrees. So hopefully if you guys can follow my math, I don't expect my students to, always show me what they're typing in their calculator. So to speed up time, I'm just going to type in the 1200 times the sine of 21 divided by the sine of 140. And assuming I typed in everything correctly, I'm getting 669.026 yards. All right. And then due to D2, I'm just going to do the same thing. 1,200 yards over the sine of 140 degrees equals D2. And then you look at the opposite angle of D2, which is 19 degrees. So that's going to be sine of 19 degrees. So therefore, D2 is going to be 1,200 times the sine of 19 degrees divided by the sine of 140. And I get 607. And it makes sense. These angles are like relatively close to each other, right? So these side lengths should be relatively close to each other. So therefore I get 607.793 as I round it yards. Now again, I did create some variables that I'm solving for, so I just want to make sure, a word problem would probably be better described. D2 is the distance to point number 1, and D2 equals the distance to point number 2, at least therefore on the diagram. All right, so that is it for the free response questions that you guys can kind of see from there. What I'll do is I'll just kind of check in the chat, see some of you guys, see Keith, Gabe, Mar, good to see you guys, Snar Nation, Anthony, Epics, Finesse, Galaxy. Oh man. You guys got a lot going on. Snar Nation says, Brian, help me. Well, let me know what I can do for you. I'm going to finish up these videos. And then hopefully I can get some questions in for you guys. So be sure to hit that like. Very good. All right. So let's take... So hopefully I'm not seeing any questions over at least what I covered. So I'll kind of come back into the chat, guys. Hopefully we'll be able to knock out these multiple choice here in the next 15 minutes. And then I'll have hopefully some extra time here where I can answer some of your guys' questions. Because I still got to get some work done for tomorrow. All right. So let's go ahead and wrap this up, this next one up. I don't know. Okay, hold on. So again, kind of word problem. It's a little bit nicer, to because we can check our answer and see if we typed in something incorrectly or made a mistake. This first question says, use the law of sines to find the missing side B in the picture. Round your answer to the nearest decimal. So I can see here I have my ratio, right? And I need to solve for B. So my ratio is going to be B over the sine of 70 degrees equals 5 over the sine of 50 degrees. And again, guys, hopefully you guys just understand what I'm typing in my calculator. I'm just going to multiply the sine of 70 on both sides. So this would be 5 times the sine of 70 degrees. And that's going to be divided by the sine of 50 degrees. And when doing that, I get 6.133, which would round down to 6.1. All right. So finally, we're going to get to a problem where there's some storing. Now, The reason why we want to store these is you can see we have seconds and minutes. And remember, minutes is just a way for us to kind of like reduce our angles here. All right. So what I'm going to do is I'm going to be storing these. Now we do have some alpha, beta, A, and then we have gamma. I think actually when this problem got drawn in there, I think I might have made some mistakes as far as my labeling. So I'll have to go and check. But this one kind of looks a little confusing, right? So let's go ahead and label what we got. Draw a triangle, because sometimes it's just going to be easier to look at what the triangle is that we have. And then we'll go from there. So obviously you can see that alpha and beta and gamma here are going to be our angles, right? So let's call this one alpha. And therefore this opposing one would be a lowercase a. Let's call this one beta. So then we'll just use lowercase b over here. And then the last one is going to be gamma. And then obviously that's going to be opposing a lowercase c. All right. So the main important thing is, I think the easiest one to figure out is, well, what is going to be gamma? So forget about the 30 and the 10 for a second. I don't know why I did that. But remember that gamma is basically going to equal 180 degrees minus alpha minus beta, right? So if you just kind of think about, like, forget about these minutes here for a second. Anyways, that adds up to 40 minutes, right? And again, there's 60 minutes in 1 degree. So we know there's going to be 20 minutes left. But so if I just did 180 minus 180 minus 44 and then minus 24, that gives me 112. But remember, there's also 40 more minutes that I need to subtract from there. So therefore, that's why the answer is going to be 111 degrees and then 20 minutes left over. And again, you can kind of think of that as, if you do subtract these, like, you can convert these to decimals. It's just not very nice with this, so therefore I'm going to leave it. But because what you'd have to do is convert them to decimals and then convert them back. Either way, when you do this in decimal form, actually, you know what? Let's just write this out again, how it would look. This is 44 degrees plus 30 over 60 degrees, right? Which is really just 0.5. This one is going to be 24 degrees plus 10 over 60 of a degree, which is again a fraction. And actually, you guys, you could just type this into your calculator either way, with fractions as they are, type them in, subtract them from 180, and either way, you're going to get 111 and some decimal, which is going to be these two answers, not 112 in these two answers. So therefore, those are no good. All right, so I'm going to stick with these answers. So now I got to figure out, well, I got to figure out my B, like which one is it? So let's just figure out one of these. Let's do B. So to solve for B here, do I have a ratio? I have a ratio with alpha, A and alpha. So my first ratio is 16.3 divided by alpha A. So that's going to be the sine of 44 degrees and 30 minutes. Now again, that is the same thing, 44 degrees plus 30 over 60 degrees. So that's just equal to 44.5. Really kind of nice. And that's going to be equivalent to my B, which I need to figure out, all over my sine of beta, which would be the sine of 24 degrees, 10 minutes. Now, 24 degrees, 10 minutes is not as easy, so I'm actually going to use a storing function. But you don't have to. You can, if you don't have a storing function, you don't know what I'm talking about, then just write it all out, plus 10 out of 60. Now, I believe this is going to be a repeating decimal, so it's going to be 24 plus 10 divided by 60 is going to be 24.16. And then obviously you're just going to be repeating that 6, right? So obviously you can't type in a repeating decimal. I'm going to store this as alpha A, so therefore I can use this. But you might just want to type down like maybe 6 is a lot, like 5 of them or something, just to make sure you're not going to have any random errors. So now what I'm going to type in my calculator, I'm going to do 16.3 times the sine of my stored value of A. And then I'm going to divide that by the sine of 44.5, because that's what I figured out of 30 degrees to be. And when I'm doing that, I get 9.52. So again, which value am I solving for? I'm solving for B. So therefore, you can see that my answer is going to be D. Okay. I truly apologize for anybody that's working on this. There was an error on this problem. So we're just going to disregard it. You guys can see that this doesn't make sense. That's a big little b, that's a big B, and they're both two angles. So I'm actually like, I don't even understand what the heck happened here. So that one, we're just not going to worry about, because there's nothing I can even correct on that one. It's just horribly incorrect. Or nothing even makes sense. So I'm like, I don't even know what I was doing. So the last one here is find the area of the triangle having the given measurements, round to the nearest unit. So, one of the formulas we looked at here for the area of a triangle, besides the base times height, is we spent time actually investigating this. So that's why I'm okay with actually just giving you guys the formula, was B times C times the sine of A. Okay, which is really 1/2 base times height. We just learned how to do that in the class. So the nice thing about this problem is, oh, exactly, you are given the A. So we got to figure out what is the C, right? Because we're given B, but we're not given C in this case. You know what? I thought I was looking at this. Oh, hold on a second. Let me check something real quick, because I was checking this answer, because once this one mistake happened, I was like, you know what? Let me check to make sure I didn't do this again. So hold on one second before I do this problem, because then this becomes a side problem. I was like, that doesn't look right. That doesn't look good. So yeah, so I just want to make sure, because when I did it that way, I still got the right answer. So I think this was supposed to be a C, and it got typed in incorrectly. So just give me a second. I will check in with this on my notes. PC simplify. What am I looking for? I don't even remember what I'm looking for. Yeah, there we go. All right. Sorry guys, bear with me. And then I'll get to some of your guys' questions here at the end. Hopefully I'll have some time here to finish those. Do some problems if you guys have any questions that you guys have in your class that I can help you guys out with. Computer obviously does not like going live. And then also me trying to open up a whole bunch of files here. Come on. Okay, so this one was find the area of the triangle. Find the area of the triangle, which is 20 degrees. Let me just find this problem, because, yep, there it is. And it was supposed to be a C. You got to be kidding me. Okay. Sorry, guys. So that was supposed to be a C. So anyways, when you go ahead and type this in, I'm going to have 1/2. Obviously, we have our B, which is 17. We have our C, which is 7. And therefore, that's going to be times the sine of 20 degrees. Okay? So therefore, we go ahead and check 17 times 0.5 times 7 times the sine of 20. And when you guys go ahead and do that, what you end up is a 20.35, which is roughly just rounded to the nearest square, is going to be a 20 square meters. So 2 mistakes that I caught on there. I do apologize for that. I'll have to go ahead and update my quiz, or update my homework for on there. But as we go ahead and wrap up the chat, let me go and see if I can answer any of your guys' questions. He said this is the most failed test of the school year. I'm like, this is the most failed test, then you're not explaining it right. Fast forward to today. Well, it's kind of crazy, Aaron. That's kind of a similar thing that I said that I was looking into. And I think as teachers, you always got to reflect. Like you always got to reflect on your instruction. You always got to reflect on your testing practices. Things that make sense. Why did a whole bunch of students struggle with the content? It's always easy to blame somebody. And I think that works both ways, right? I think for students, it's always easy to blame the teacher for not teaching it correctly. And as teachers, it's always easy to blame students for, not paying attention or not doing their homework or whatever else. So we could always play the blame game back and forth. But I don't think that really gets us anywhere. I think the best thing that you're going to grow off of is, taking the ownership model and saying, what could I have done to have been better? As a teacher, how could I have taught this content better? Should I have slowed down more? Should I have, enforced that more students were doing their work or that were understanding the material after they left the classroom, right? In the same respect as a student, you guys hear your question, what could I have done to understand this material better? Could I ask some more questions? Could I have stayed after? Could I have, done some extra problems and so on and so forth? So, it's really easy to blame, I think, on both sides. And obviously you always want to blame, right? Because, it's tough to take the ownership for something, especially if you don't get the result you want. But if you are able to reflect on it and really make those hard acknowledgments of saying, I probably could have done something different. And even though there might be easy something to blame that is totally correct on the other side, it's not going to really get us. It's not going to really get you very far. Just always blame them and just say that's the reason why I failed, or that's the reason why my students failed the test. Is because they're not doing what I'm telling them to do. So, from what I've found through my experience is, whenever you are not getting the result that you want to, is always kind of, turning that back onto you and saying, what could I do better? And just continue to grow. And what that does is that, you help you grow and you get better from it. And then guess what? It happens again. And then you do it again. And that's like kind of life. I mean, that's how you grow, through different things in life. So there's just a little bit of advice to you not to beat your method. Checking in Jesse. LaFontaine said, do you teach in Michigan? No, I do not teach in Michigan. I am from Michigan, though. So I'm born and raised in Michigan. Spent my first 23 years in Michigan, and then graduated and came down to Jacksonville, where I've been teaching at the same school since I got out of college. So it's been a pretty cool thing. And I've been teaching since 2007. So this is my 11th year as a teacher. So it's been kind of cool. I've always kind of thought, one thing I always say is throughout my whole life, I've always gone back to school in August, all through grade school, right? And then high school. And then I went right into college. And then right after college, I went right into teaching. So I'm like, August is that back to school. I don't know any different. I don't know anything different than, at least in the American school system, the summer's off and the winter break and all the other holidays and stuff. I just don't know any different. I've never had anything different, which is cool, but it's also kind of crazy. My whole life up to this point, I've always had those times, obviously when I was not in school, but still it's kind of cool. Or at least I thought it was kind of cool. All right. You're right. You only have control of what you can do. That is absolutely, correct. And, and again, nobody's at fault for me making a mistake. I don't even know how that happened. It's just an error. I was probably doing it after my live stream on Tuesday night and wasn't, was half asleep. But I mean, the same thing, so obviously I got to do better. I got to hold myself accountable, for on this. And then, students though, they could have figured out once they did it with A and did some math, they figured out, oh, this doesn't give me a solution. He made a mistake, but maybe come in, ask some questions and so on and so forth, and make sure you understand at least this formula. And we covered this in class. So, it's a fairly basic problem that we were doing for this. All right. Can you give me some tips on how to get a 90% overall in my math class? I only laugh just because there's, it's not really, it's a funny matter. It's just, it's very vague. I don't know what class you're taking. Just some general tips or some vague, some general tips from you. I always look into is, one thing I write in my ebook, get help. Work with people. I'm glad you're on this live stream and getting help with me, But, when you're doing your homework, find some people to do your math homework with. Like, not only some people that are, smarter than you, but also maybe some people that you can explain stuff to. Like, when I got into my tougher math classes, the best thing that I think helped me learn and do well was I was around other people. I did my homework with other people. I studied for tests with other people. So I know it's kind of odd, especially maybe if you don't know anybody, in your class or really well. And it might feel like a weird thing to do, it's like a study group, but I can tell you, hands down, those harder math classes that I was taking, when I was working with 2 or 3 people and we could like brainstorm together and figure out how to do the problems, it was the main reason why I was able to pass some of those classes, just because that synergy that you get, doing math with other people and talking about the math and talking about the work helps you understand things better. So to give you like one little tip, I would say do that. Besides that, ask questions and, hold yourself accountable for understanding the material, because, there's a lot of tips and tricks, to like pass a test or pass a quiz, but 90%, you got to think, if you want a 90%, ideally you want to be understanding 90% of the material, right? Or you want to understand it 90% well, right? So, hold yourself accountable. It's not so much, oh, can I do this to pass the test? But it's like, do I understand, what is on this test? Like, because, as I don't know what class you're in, but, sometimes it's not always just I do and then you do on the test. Sometimes it's a lot of the questions on the test are, challenging problems. They're really going to challenge, do you actually understand the material? So just kind of focusing on, your notes and knowing the basic stuff might not be 90% worth the 90% in your class. And again, I don't know what your class is or, what's kind of covered in there, but those are just some things. But I would definitely get with at least a partner that you can study with, do your homework with, to really make sure that you understand the content. Well, I think that's something that, it wasn't something anybody told me to do. It's just kind of, actually it was probably one of my lower classes. But it's something that's really, really, really helped me out. All right. Would you rather use the Pythagorean theorem or find distance formula to find the distance or the distance formula? Well, the distance formula is derived from the Pythagorean theorem. So it really kind of depends on what information I am given for what I'm going to use. So, but it's really the same thing, basically, as far as applying the Pythagorean theorem or them. So, software taking geometry pre-calculus. I really like your videos and help and appreciate it. Well, you are very, very welcome. I'm so happy to be able to help you out. And thank you. So, Braylon, math gives you power. MCO parkour. Seriously, you've helped me. My review packet. I look forward to using your videos as college calculus. Well, awesome. Congrats to you going into college calculus. That is awesome. Keep up the hard work. Arson, LOL. Yes. Good to see you, Sam. Can I bring a hoodie concept in class tomorrow for your merch? Sure, man. I gotta update my merch. I know my merch is definitely slacking here. But I don't know. I think actually maybe after this chapter, once we're done with this chapter, I think my workload should slow down a little bit, because I have a little bit more already completed for the other chapter. So this chapter, though, I don't have any of the content created. So every night I got to be creating like the next thing. Like I have up until now, until our quiz, but now I got to do the next 4 lessons after that, and the notes and the investigations. And the more I think about it, the more stress that kind of comes up. So either way, I'm sorry, guys, if I didn't get to your comment or give you a kind of shout out. I'm not trying to give everybody a shout out. That just as many as I can, but there's a lot of comments. I really appreciate you guys joining in on my live stream. Hopefully those of you that were looking into learn something about the law of science, you got some useful information. Otherwise, I will look into going live. Let's see, we're going to be taking a quiz on Tuesday, Thursday. So yeah, I'll be live next week. Keep it in your calendar. Subscribe and notification if you think you're going to forget. But I will plan on going live next week on Tuesday and Thursday. So therefore, we'll do a homework live stream on Tuesday, and then we'll do a quiz live stream on Thursday. So otherwise, guys, and again, I'll make sure I post on my Facebook group. So therefore, if you have some questions that you'd like me to address for your class, please go ahead and post on there. But otherwise, guys, I am going to get out of here, get some work done before I head off to bed. So see you later. Thanks for tuning in.